Welcome back, everyone. We hope you had a refreshing lunch and some good conversations during the break. My name is Tenzin, and I'm a faculty at Paro College of Education, and I will be your MC for the afternoon sessions. It's my pleasure to guide you through the wonderful lineup of presentations, discussions, and reflections ahead. We move into our afternoon program with Thematic Area 2, Climate Change and Environmental Dynamics in Bhutan and the Himalayas, a theme that lies at the heart of Bhutan's development priorities and the resilience of Himalayan ecosystems. This thematic area explores the complex interplay between climate systems, environmental change, water resources, biodiversity, and adaptation strategies in the fragile mountain landscapes. Before we begin, I'd like to inform the audience of a small update to this afternoon's program. As listed in the schedule, this thematic area features two sessions, Session 2 and Session 3. For Session 2, we were scheduled to have 4 presentations. However, due to unforeseen circumstances, Dr. Om Katel will not be able to join us today. We will therefore proceed with 3 presentations for Session 2 of Thematic Area 2, followed by the scheduled Q&A session, for which we will now have a little more time than originally planned. Ladies and gentlemen, to open this thematic area, it is my honor to invite our keynote speaker, Professor Dr. D.B. Gurung from the College of Natural Resources, Royal University of Bhutan. Dr. D.B. is a leading figure in Bhutan's environmental and natural resource research. He began his career in the Royal Civil Service and later helped shape the College of Natural Resources as both Dean of Academic Affairs and Dean of Research. A professor of forest science, he has led major international projects and contributed work in biodiversity, taxonomy, fish diversity, and Bhutan's changing climate. Today, he will speak on the topic, Beyond Adaptation, Resilient Future Solutions to Climate Change. Please join me in welcoming Dr. D.B.
Hello.
Excellencies, Dassos, distinguished guests, participants, ladies and gentlemen. A group of us are working behind to look into the future with respect to the climate change. I'll introduce this group later on in the middle of the session. So what I'm basically trying to provide you with the short note is that we have to look to the future, knowing that the climate change, how the climate change is impacting us. We have to look to the future where we are able to deal with this climate change situation impact. How can we reduce it? So I'll be getting into the trajectory, risk, and the transformational resilience that we need to work out. Since I'll be presenting you with some models, let me start with this small statement. All models are wrong. All models are wrong, but some of the models are useful because they help us make decisions and help us plan properly as per the decision that we can take. So therefore, we are working on this. So I'll show you some of the models are straightforward, some of the models are a bit complicated, but we are not going to discuss this. To start with, let's look at this. NCSM has done a lot of work related with the climate science, climate change science. Look at this situation, annual average surface temperature, very simple model. What you see that is that there's the zigzag line, that is the pattern of the changes. That the yellow line that you see is the trend between 1951 to starting from all the way to, you'll see that in 70s, how it was. Then after that we have from 70s, again the 2000s, and we have the current one. Now we can see that in the current decade, the climate change, the temperature rise is sharp. The temperature rise is really becoming sharper and sharper over the decades. That's about the temperature. Then coming to the next one, projected trend of the temperature. Let's look at that. We have certain scenarios based on the IPCC. So in this scenario, the first scenario, we have the all controlled aspect, low emissions and so on. The middle one is basically we have middle path. So and the last one we have is the worst case scenario. In these three scenarios, how is the trend? The brown one that you see, the zigzag line at the bottom, very short one, that's the trend that we see now. And what we have is with the green one, that is the best scenario that we can think of. And the reverse scenario, in the worst scenario, we have the red lines. So these are the scenarios that we have based on the models in relation to the temperature. Looking at this projected temperature trend until 2040, now we are in 2025. So if you look at that, you can see that what are the possible changes. In this side, you'll see that more bluish color. That's the minimal temperature change that might happen. And that could be at the 1 degree Celsius at the bottom. So you can look at that, how it is changing with the different models and the different scenarios, how the temperature might change. A lot of work has been already done. We know this. And in the worst scenario, we can also have that by the 2040, we might have at least 1.7 degree the rise in temperature. That's the worst case scenario. So even 1 degree rise in temperature could be devastating for us because some of the snow glaciers might melt faster than usual. And the temperature still rises up, and if you look at that, at the bottom we have 4.4 degree centigrade temperature rise estimated in the worst case scenario. That can be really catastrophic for us if that happens, but then we are expecting that that will not happen. Coming to the precipitation trend, what you will see is that in the later half of the last century, over the somewhere between 50 to 70s, we saw that we have seen that the actual precipitation, rainfall as well as the snowfall and so on, they were going down basically. Average precipitation going down. But then it started changing again. It started increasing from 1970s, and in the last decade it is really rising up. The rainfall is really changing faster. So it is increasing. Pattern has become erratic. If you look at that, this and the next slide, you'll see some bluish lines, most of the bluish shades. If you look at that, you can expect that by 2040, the western region, especially Punakha, Garsa, and so on, these districts might have more rainfall. But in the east, in the east, southeast, especially the yellow part, it is likely that they will become more drier than what we are seeing today. So this is the scenario. So you can see that is increasing. Coming to the mass glacier balance, the how much snowfall and how much is melting and all this, that balance. If you look at that, you have mostly on the top, on the higher Himalayas of Bhutan. So you can look at that, how it is changing. And the effect is mostly in the Wangshu River Basin, Punachangshu, and in the west mostly. So you can see that effect. You can see that, how the mass glacier, the mass balance might change over the years. Coming to the glaciers, if you look at the red lines down here, the rate of glacier change, glacier retreats every year is very alarming, especially in Thana region. It is about 23 meter per year, 23 meter glacier retreat per year. Very alarming for us. So very high. And of course, Gangju, we have 13 point something. Average for Bhutan, it will be low, but then if you look at individual glaciers, some might be very, very high in some of the cases. Quite alarming for us. Impact of the cryosphere, look at the glacier lakes, we have that 567 glacier lakes. Some of them are potentially dangerous, and look at these potentially dangerous lakes here, which are potentially dangerous glacier lakes, all on the higher Himalayas. And you can look at the Gulf events over the years, how they have been changing. So this is the picture that we can present now. These are things that we know. So they are there. And also look at that unstable, not instable. Landslide. Landslide is very dangerous for, which can, they have a lot of impact on the loss, the properties, loss and so on. We have about basically 993 sites covering about 26.6 kilometers square landslide areas. And if you look at somebody's work, again, it is worst, the right side, very much red. What triggers landslide? If you look at this, about 42% is because of the climate change. 40% of the landslide is triggered by the climate change in Bhutan, landslide events. And about 28% of the landslide events in Bhutan is because of the road undercutting, road construction. So this type of scenarios are available now. So now the issue is now, glaciers are melting fast, rainfall pattern is changing, temperature is rising. What we do not know is, what is the situation with the permafrost? So that's what we are basically talking about that. And collective, the effect of all of this might be bigger. Some of the events in 2023, again NCSM, so you can look at that. I'm not going to talk on this so much. Look at this line, climate change related events. 1995 and over 2025, we have so many events, sharp rise in the number of the events related to the climate change. These are the sources, that is from where the information has been gathered, so it's quite alarming for us. Again, the extreme events are there. I'm not going to talk about so much of that in the extreme events, including Ayla in 2000, the cyclone Ayla in 2009. All these things have triggered a lot of the landslides in the country. Gelefu, few years back, a lot of devastations in the southern part, Gelefu, Funsiling area, flash floods and so on. You can look at the data. I'm not going to talk so much. And where are our vulnerabilities? Basically looking into that. So our hydropower section, another one is agriculture and tourism. These are the areas that where we need to be cautious about, where the climate change is going to have devastating effect on our economy. So these are the areas. Population exposure to monsoon, if you look at that, around 19% of the total population are exposed to the high level of increase in the precipitation by the turn of this century. By the turn of the century, it will be about 99% in the worst case scenario. This is about the worst case scenario. Again, you can look at how the temperature might change. I have already talked about even that 4 degrees centigrade increase in the temperature by the turn of the century can have a lot of impact in our economy. Exposure to agriculture, again look at that, about 54% to 66% in the SSP3 scenario by 2040 and by 2060. So these are the projections basically, these are the projections. Vulnerable areas, international airport, Paro, domestic airport, Bhutan. We have the hydropower sections. All of this dam will be under exposed to vulnerability, including the monuments like Punakajong. These are the areas that we can think of. Where are the things coming up? Where are the events, the climate change related events having effect in our lives? So risk assessment basically done through the hazards, exposure and vulnerabilities. All of this put together, we can calculate the risk. I'm not going to talk so much on that. Currently we have a project funded by the National Swiss Foundation. That is the Cryosphere project. It is in Siena. It is a collaboration between the WSL Switzerland, Zurich, the FIWORK University, the NCSM in Thimphu, and the College of Natural Resources. So we are working on that, and we are basically trying to look at the permafrost for which we do not have information so far. We have Pimba Eden, our PhD student is here with us today. So she is working currently trying to map the level of permafrost in our country. Last year, a team of 5 women, 3 from Switzerland and 2 from one from the Bhutan and 1 man from NCSM, went to Thana, and they put some devices, automatic weather stations, that would send us the data, live data. And also we had the data logger placed on the way to Thana. And out of the 20 that we have put, 6 of them were lost. This year we went back, the 2 of them went back and found the 6 of them were lost. So this is the situations. You can look at that. So that's this year's trip. What we can see is, again, related with the permafrost. This is based on the world the data, for which Bhutan is almost that much. Only that much, not so very good, but this is just probable projections. And in terms of this, these are the models that we're using, GLM, GAM, RF, X. Then we are using the ensemble. Based on the ensemble, we have about 2,700 square kilometers of permafrost in our country. That's the estimation that we are arriving at. PMI has come up with. The question is now, behind science, what is it? We have deep societal shift. We need to do that. We know it, but we don't do it. Systemic change, we ask everybody to do it. We don't do it. Digital solution, we have it, but we don't use it, make use of it. Again here, smart science, smart citizens. We are looking into that direction for the future. We want to have a society who are not only well informed about the climate change and its impact, but they are well educated in terms of the climate change and its impact, so that they can act even before the events occur. That's the requirement that we need to look at. That's the area that we need to focus. And how do you do it? You can look at that. Some of the example. All our cities and the urban areas are concretized. We can do it differently. I would look at that, even the use of the soft engineering that is required, which we are not doing it. Our engineers are here. I do not know what is the problem with that, but they should be acting on this. So these are the issues that we should be looking at. And finally, I would like to stress that the issue with the higher or the tertiary education is that we need to be able to communicate with our governmental organization as well as the funders, donors. If we cannot connect to these 2 groups, major groups, we will not make it. As the higher tertiary educations, the provider, it is our responsibility that we make these dots connected together. That's very important for us. Thank you very much.
Lasla, thank you, Dr. DB, for talking about climate change, a phenomenon that we sometimes forget is happening as we go with business as usual. So thank you for making it more tangible and a very timely and apt reminder to go beyond conventional approaches to become smart citizens and make that paradigm shift. Our next presenter is Jambe, who will be joining us online. Jambe is a PhD candidate at the Australian Rivers Institute, Griffith University. His work focuses on understanding drying water sources in Bhutan and designing restoration strategies that directly benefit rural communities. Prior to PhD, Jambe served as a lecturer at the College of Natural Resources and has extensive experience in watershed and springshed management. His work demonstrates a strong commitment to sustainability, community well-being, and using science to improve society. He will present on the topic, Hydrogeological Assessment of Drying Lakes and Restoration Strategies, a case study from Dagapela, Bhutan. All right, please welcome Jambe. So Jambe, can you hear us? So Jambe, can you hear us?
Yes, thank you so much.
Lasla, please, you can go ahead,
Lasso, good afternoon, everybody. Firstly, I would like to begin with acknowledging the presence of Honorable Bhutan's Ambassador to Australia, the Vice Chancellor, the Royal University of Bhutan, and all the extreme scholars and colleagues who are attending both in person and online. It's a privilege for me to explain about the work that I have done back in Bhutan. Currently, I'm doing PhD, and this is the part of my work. So what I'm trying to present here is like, it's based on the case study, like it is the assessment of the lake, and also trying to find out like what can be done so that we can restore the lake ecosystem back. So before I start my presentation, I would like to thank the people of Bushi Gyeok and also former NC Dashu Suyamman Thapa, who played key role in this work. So like a lot of reports over the year has been coming across the country that spring water sources are drying up. And also in parallel, there were some records coming up like lakes are drying up in the country. And it's an opportunity for us to understand that lake and the springs are very much connected to each other. Like drying up of lake will ultimately cause the drying up of springs, because for those springs which are pouring at the bottom of the mountain actually are linked with the water reservoir which are on the top of the mountain. So when lakes dry up, it's not only lake which is drying up, but all the springs which are at the lower catchment, and also the bigger river, and ultimately whole community who are depending on those springs, rivers, and lakes are put into threat. So therefore, it's very important for us to understand what is happening around our lakes in Himalaya. The various lake studies has been focused on those lakes in our country and in the region. And it's been a lot of reports coming across the communities, like lakes are drying because plants are growing on top of lakes. And also one scenario, we can think that lakes are drying because plants are drying on the lake. And also at the same time, we can reverse the thinking, like plants are growing on top of lake because lakes are drying. So like it's story like eggs and egg in the hand. So these are some verbal communication that we had in the field visit that we did in Dagapela, Bhutan. So there's one newspaper which I have pasted here. It says like 4 of 6 lakes that supply drinking water to 4 gyots in Dagapela have disappeared. So the interesting thing about this is like the importance of lake for the drinking water has been clearly understood. So with this, I had opportunity to visit the lake, and then this is developed the study. Like in the global studies, we came to know like around the quarter of the lake in China has been drying up. So it's very severe. And also the reason behind their study says like it was all because of changes in the land use pattern around the catchment. And that is where actually we started to think to assess what's happening around the catchment of the lake, and also effective restoration of the lake. Like also it's a very site specific, like different lakes needs a different intervention based on the catchment. And also in our context, as such, at currently we do not have anything which directly pronounced like we have like a lake restoration framework in the country. So it's very important with the reports coming up that lakes are drying up. So it's high time that we develop some management or framework or restoration planning around those drying up of water sources, drying up of lake sources. So main intervention currently being done is like planting trees around the catchment has been repeatedly seen as intervention being done. So in this regard, purpose of this study is to understand why lakes are drying at the first place. And second is why they are drying. And third is what can we do at least to not necessarily stop, but at least to reduce the speed of drying up. So with these 3 objectives, we went to the Dagapela, and then this is the picture of how the lake appeared on the field. So Goshi is one of the gyok in Dagapela. So in that area, there were 5 lakes that we have studied. So the Lampokari lake happened to be on the top, and then there were 3 lakes which were unnamed. So the community out there, they say it's a Jol Pokhari. So Jol in Nepal, for some it means lake. So interestingly, like while studying the catchment around the lakes, we came to know that all those lakes are actually interconnected. Hydrogeologically, after studying this, we concluded that all those lakes were interconnected. And also we did a very detailed study of how like rainfall pattern or like temperature has changes and what all changes has taken place place around the catchments of those lake were also thoroughly studied. So in that case, all the coordinates of those lakes were taken, and then historical events of the lake were assessed to find out the catchment and the size of the lake. And it was true that that lake was really drying up, and all some of them were in the process of drying up, and some of them has completely dried up. So we had a good time to go around the lake. In scientifically, we say it's a belt transit. So we went around the lake, and not only lake were studied, but also the vegetation around the catchment, along the rocks, type of the rocks, alignment. So all these features were studied in this case study. So also water quality we have tested because through water quality we can say many things about lakes, and the like tidal pattern of the lakes has also been noted. So ultimately, the finding of the lake is that these are the location of the lake. So progressively, you will see in the picture like those lakes are in the drying process. So the lake, the bottom lake, which is Jalpokhari Sea, has completely been dried up. But those lakes subsequently, when you go up, so little bit of there in the process of drying. So what does this indicates is like the important finding of this lake was very inspiring in the sense like if we are able to revive one of the lake, so our prime scenario or prime aim here was to revive the lake on the top. So if we are able to revive the one lake, so subsequently many other lakes also will be able to revive in this area. And not only lake, so ultimately we didn't study it, but we are pretty sure like people in the community have also understood that these lakes plays an important role in the drinking water or the spring water. So it was very important for us to find why it's drying up. And then one reason, obvious reason that we have come across was here where a lot of catchment changes has taken place around the lake. So catchment changes was one was that earlier that lake, particular lake, was not densely covered with the vegetation, but now with a lot of reasons, farmers out there say that it used to be like plain earlier, and then it was a place for them actually, like they used to look after their cattle. Now it's highly invaded by plants, and then and also in the nearby catchment there were a lot of plantations being carried out by different organizations, and then those were some changes. So what happens is like when catchment becomes so dense, then when it rains, rain is no more able to go into the lake, because the water that comes inside the lake ultimately is the rainwater, and also the nearby gullies. But then those gullies and all those catchment were highly dense, and then water no more drain into the valley. So it was also one of the observations that we have noted based on the very short case study that we have carried out in that lake. And another lake was a little bit away from those 4 lakes. There was Dunkar So. So this lake, interestingly, was below the road. And then this lake used to be a very big lake, and still there are some water that I have shown picture here. But what happened is like sedimentation was main problem in this lake. So there were very thick sedimentation deposited in a lake. That was obviously because of the road above. Like road was like gravel road, and then when there's rain, so everything actually was drained into the lake below, and then when it's rainy season, so it was completely soaked with all those sands. And also there was old gullies above the lake, above the road, which was cut while constructing this new road. And then our recommendation here was also to reconstruct those gullies and then send the water into the lake, but also to come up with a filtration system whereby sand doesn't go back to this lake. So very specific intervention for all these lakes are detailedly explained in the paper that we have written for the reporting of this work. And ultimately, the interventions which were, as I mentioned, like different lake has different interventions. So general intervention is like dredging the bed of the lake. So taking out the space for new water, more water to accumulate. But at the same time, it's very important that there are some impermeable layer, which is very important. If we happen to take out those impermeable lakes, so then rather than water accumulating there is a risk of infiltrating or percolating water down. So it's very important for us even to note those thickness of the layer. So all those were being done, and then those are being indicated in the report that we have submitted to them. And ultimately, pH of all those water were measured, and then the purpose of the pH is to understand like whether, to very simple examples, to understand whether there's a drying up of lake, whether because of the pollution or not. Example, like if the pH gets very less, then it means a lot of organic activities are happening, and then it's contributed by pollutions. But happily, or like as expected, it was not polluted lake. The pH was very high, except one of the lake which has 5.6, which is also not very bad. So chemically, this lake is not stressed. It's not because of pollution is drying up. So that's not the reason that we have concluded. And also, in terms of temperature and rain that we have analyzed, there was a good amount of rain and also highly correlated along the temperatures. And our recommendation for the carrying out those work were butane not during the rainy season. That's based on this column. We understand, like histogram, we understand that May and September is somewhat a heavy rainy season. So this should be carried out in non-rainy season, so that when it rains, like it doesn't drain. Rather than benefiting, sometimes there's a risk that whatever we have taken out or whatever clearing of catchment we did may end up in the lake. So it should be done when it's not a rainy season. So specifically, we have also given a season that is when it is an ideal season for doing this. So ultimately, this study was a little bit of very complex in the sense, like it's the first time that we are trying to understand lake hydrogeologically, like not only at the surface but also below the surface, subsurface, like how the lake actually is connected geologically was also being explored in this study, along with beautiful finding that all those lakes were highly interconnected. And also we conclude that this lake, particular lake, was not chemically stressed, so their pH was good in the sense like it was they are not polluted. And also our recommendation for restoration work was we say like restoration window was from October to April was a very good time to carry out this work. And overall, we think that our team, we think that this is one of the paper which gives some foundation of the lake restoration framework that we can think for other lake in the country as well. So with this, that's the end of my presentation. Thank you so much for your time, and thank you so much for listening to my presentation. Thank you.
Hello. Thank you, La. Jambe, for that insightful presentation where we got to look at why our lakes are drying up, what we can do to revive it through this amazing interconnected system that they're embedded in. Please remain online as we will see you again during our Q&A session shortly. Yes, thank you. Thus, ladies and gentlemen, our next speaker is Dr. Ishe Khandu, a lecturer at the College of Natural Resources and a specialist in dendrochronology, the science of studying tree rings to understand climate and ecological change. He's the founder of Dendrochronology Laboratory at CNR and brings deep expertise in forest ecology, climatology, and Himalayan cryosphere and permafrost environments. His presentation is titled, Dendroclimatic Reconstruction Unfolds Chronicles of Climate Change over Northern Bhutan Himalayas. Dr. Ishe.
You may be wondering what this dendrochronology is and why for the climate reconstructions. So I would like to take you through the principle and technique of this dendrochronology, including the functions, applications, and uses. And finally, the policy directives for these reconstructions. So this is the science that that studies about the things with the dating and then the structures, and with their structures interpretations to interpret the environmental, climatic, historical, cultural, and then the processes that were involved within this. See, referring to the figure, given here, we find that different factors are interacting with the trees and playing with the trees, and this what about the interactions made by all these factors are recorded by trees. Now, what the expert will require is to extract those informations, and how we will go with this. So this is the principle of the uniformitarianism and then cross-datings. So this principle allowed us to get back to the past for thousands and thousands of years, not only the few hundred years. For example, reaching the record back in time using the treating sample from the living trees, dead trees, and also from the archaeological sites, those thousands of years back. So this is what is called the principle of uniformitarianism and also the cross-datings. Let me go further with the principle of the uniformitarianism. So this is, so as per the James Hilton, the British geologist, that facing is the key to the past. And with this now, going down to the correlate to this principle, past is the key to the future. So that's the fundamental principle of the dendrochronology. Now, using this, territory of the science, past, present, and the future, we studied the process as they occur at the present. So what about the process, natural process that happen today has been happening in the past, and also will happen in the future as well. And now with this, with these studies, they involve the understandings. All understandings come from the past, and then to go and with this using, to extrapolate and then predict for the futures. So that's the very fundamental principle of the dendrochronology. And now this another principle, aggregative growth models. So this is we use to conceptualize this response and to understand the different variables that affect the tree growth. As shown earlier, the various factors influence the tree growth. So, and now, which factor we want to go? And then here we use the principle of the tree aggregate growth. That was the PhD thesis output by the Dr. Edward Cooks in 1985. So this is the mathematical formula we use. R is the tree ring, then A is the H chance, C is the climatic signal, D the internal disturbance, and E due to the external disturbances and so on. Now, what we look at with this is we have to twist this apart and then get down into the right into the signal and then to remove the noise that we don't want it. And this is, as per the page, the endochronology is considered as the most useful methodology to inform about the past changes because of its annual resolution and absolute datings. It can pinpoint the correct year, correct seasons, and so on. So because of this advantage, so page considers this as the best methodology among the other methods. So this is one of the conferences mentioned in that page. Study the past climate to inform for the future. So without studying about the past, there's no way to go for the future. And now see the problem with the Bhutan. In the Himalaya regions, climate change, environmental change are happening at very high rates. Now to go with this and to make with this, to align with this and to find out how to go with this, for the present management and then for the future directions. Then economy is the best. You see what's given there is a long methodological record is a matter of concern for developing the chronology of climate sensitivity proxy data in Bhutan. So that's lacking in the Bhutan, So now, but then the chronology will be theoretically of high potential for extending the short methodological records back in time with species in the high elevation forests and the trees. And again, there's the reason why we select the sites in the high altitude regions, for example, the tree lines. So the trees standing in those forests are very sensitive to the climate change and then environmental changes. So these are the objectives. To explore or to discover the dendroclimatic signal in the teething chronology of these two species, Apis densa and species spinosa, that growing in the extreme ecotone, and to reconstruct, if possible, by extending beyond the past 700 years. So with this, I'll present you the time scales going back to the 700 years to this presentation over the northern Bhutan Himalaya. So this is the methods study site that I have used in the very extreme northern part of the Bhutan along the Tibetan and Bhutanese border. And this is the exactly line within the adjacent to the glaciated regions. So these are the research sites that I have used. And these are the methods that I use, to go to those high sensitive, to get the very sensitive, climate sensitive tearing samples. So you have to go with the, like snowman trackings and also through the use of the milk tracks and as the last option in search of those very sensitive tearing samples. And this is the methods that I have used for the transportation to reach to the research site now. These are the ones. These are the field methods that what I did in the field now to collect the samples, to call the teething samples from the trees from different sites now. And this is the laboratory methods that involved. So this is both field and laboratory methods are very scientific and very technical. So again, these are how I do analyze the samples in the laboratory to finally assign the calendar years, and then based on the calendar years to detect the climate signal, for example, temperature signals. So for example, there are many signals we find in the trees, precipitation signal, climate signal, soil factor signals, and so on. So everything and using other as noise and using this temperature as an interstate signal. So that's how I obtain to these methods. And now this is the grid data. So Bhutan do not have the Bhutan is lacking the instrumental data. Hardly we do have the 20 year ski data, and beyond that we don't have. So therefore, I use the British Atmospheric Data Center, CRO. So that covers more than 125 years ski data. So using those data interpolated into the context of the Bhutanese situation, and then I use And you will find the rectangle box up there. So this is the areas that I used to collect the samples as my research site. And also these are the areas, the grid data I used from those rejoins. And with this, the chronology I used, there are two chronologies, 1765-2017 and 1223-2025. So with the 1765-2017 is the published paper that I published back in 2020, and then this 2020-25 is the preliminary analysis results. Then these are the methods, to find out the climate relationship and then reconstruction the approach. Now, before going for the reconstructions, we'll have to find out whether there's any association between the climate temperature data and then teething data. So if there's a very good correlation association, then only you go for the reconstruction using the general software programs. Now, for this, how I built the model was 1960 to 2060, 1960 to 2025 as a climate data from the British Atmosphere Data Center, and then this was validated by the other half, 1901 to 1959. So then what the result we found here. And with these results, I also use now, just using what the result we found now, that's not enough. We have to compare with the other results from other parts of the world, And then for that, I have used the extratropical, that climate data, is reconstructed climate data from the extratropical northern hemisphere. So that's the latitude lying between the 40 degrees Celsius to the 17 degrees Celsius. And I also used the IPPC for both 2021 and also IPPC for 2013. Now with the 2021, the IPPC has focused only from the 1815 only, most part, but going back to the past, so IPPC 2013 is the best. They have covered more than 2,400 climate data they have used with the IPCC 2013 game. And this is the correlation that I found between the tree and then tree growth and then climate. And there was a very good relationship in terms of the correlation coefficient. So with the given this current year from January to December, with all the months, very good and the significant correlation coefficients, then I have gone for the reconstruction of the temperature. So this is the method that I've used, There we find the red line spanned with the black curved line. This is the Bhutan reconstructed temperature starting from 2017 to the 1755. So that was the publication purpose. So now, in the very similar styles, I have compared with the other reconstruction as well. Therefore, from the extratropical northern hemisphere reconstruct temperature. So that was a very good match. See, the correlation given was 0.75 and 0.78. Not only with that, when I used the global climate data starting from the duration of the time span of 1850 to 2000. So that's the QTM, that's the instrumental data. Now, here the longest chronology so far constructed for the Himalayan regions, covering about 700 years old, and with this I compared with the extratropical northern hemisphere reconstruct temperature. So there was a very good match. Even you find the black horizontal lines that shows the very good match between the two reconstructed temperature. Then going down further, I also graphically compared the earlier reconstructed temperature and with the recent reconstructed temperature. You can see very good match here. Look at this. See, now with this we find recent years very high rate of increase in the temperature as compared to the past. Look at this. Now, going down further with this now, see, going down to the last bullet points, the warmest period occurred in 1990 to 2025, and before that, there was also occurred in 1690 to 1770, with the coldest episode of the past. And now, with this, we find both the reconstruction displayed drastic increase of the warming from 1990 to 25, not quite matched in the instrumental temperature records. So teasing data shows the highest rate as compared to the instrumental data. So therefore, if you are given the choice, which one you will choose? So if given the choice, I will choose the teasing data. I will not go for the instrumental data. So there are various reasons why you go for the instrumental data, why you go for the teasing data, because this is nature made, nature recorded. And now here is just even I just assess how the volcanic forcing, volcanic eruptions affects the Himalayan region, for example, Bhutan, and we found there the volcanic eruptions occurring in, for example, Indonesia, Krakatau, Mount Tombora. For example, Mount Tombora that occurred in 1815, and that caused the temperature to drop down, and that 1986 was the year without summer. So that's the given. Now all this reading data shows, the data shows Bhutan has been and is and will be affected by this volcanic eruption in the future as well. So now this recent reconstructions shows the recent warming is the coincident with the reduced number of the volcanic eruptions coincides, and also the rising of the insolation and then increase of the greenhouse gases. See, look out how the volcanic eruptions affect it blocks the sunlight because of the throwing of the ashes into the different atmospheric layer. So these are the recent eruptions. Krakatau and then Mount Pinatubo. And the next is how this reconstructed temperature, just showing that temperature is rising at alarming rate. It's not enough to prove that now what impact is given, for the ecology. See, on the dynamics and regional expansion of the Chilean ecotone and the influence of the climate change. I'll show you this one. And see now here, this is the study made in the Chilean ecotone. Diverse Chilean ecotone, how the Chilean is shifting up because of under the force of the warming. Look at this. In the past, before 1845, the trees were there. Now it has reached to the top. See, look at this. From down to the top, it's climbing up. Tree lines are climbing up, shifting up. In the past. So this presents the 8,000 observations and then diverse different parameters. 8,000 observations and measurements are there in this record now. Now it has reached to the top now. And see how the tree lines are climbing up. Tree lines climbing up because of the climate change, because of the global warming, because of the, now when you say global warming, the Bhutan is also warming as a part of the global. Next, so this is the, see now temperature zone, that I have made, that I have analyzed, and then I find this is the data comprising more than 45 years data, and then this is the temperature zone. Now that data was only up to 2016. Now with this data using the 45 years, now after 15 years, again using the same method, if we plot this map, we'll find the change in there, whether the heat zone is shifting up or not, as the shifting of the tree line only. And this is the conclusions. So whatever the calibration variations, matrix shown over here, all shows that this tree evidence and spinulars are sensitive to temperature and vulnerable naturally occur to stage the global warming and natural forcing. And then this also shows that they are the good indicator of the volcanic eruptions, and there's a very impacts by this volcanic eruption. And so they also indicate the insolation and impact of this rising of insolation and increase of the greenhouse gases. And then further, now with my publication so far made with the tree line ecological dynamics and regeneration expansions, tree lines act as an indicator of the climate change. Now, because of its acting as indicator of climate change, this is the key to serve as a line of bioclimatic reference against which the other zone of bioclimatic define. For example, somewhere in 2023, the of Simtoha said that she will uproot her remaining apples and peaches and plant the pomegranate and oranges. I find in this a very big take-home message. What does it indicate? What do you find here? from here. She is not a researcher, she is not a scientist, but through her observation, through her experiences, tells us that when the tree line is shifting, other ecological zone is also shifting, perhaps. So when I shift it now, act according to that, shift the agriculture crops as well as to the high altitudes. So that's the take-home message I got from this research. And it's very great important to continue work to extend the data set back to more than 4,000 years. This is my attempt for the future, for exploration of regional expansion of the Little Ice Age, middle climate, Gulf, flood, and volcanic cooling of the past millennium. Now, this very highly skillful theory is construction of the mean and time to show that annual to multi-degree center of the Himalayan region ecosystem and the dynamics of the vegetation, growth, glacial element response to the changes in the atmosphere. Then lastly, the map shown up there, temperature and then elevation distributions of ecological zone, agriculture, plant crops distribute under the changing climate. Now, what do we do? Understanding the relationship of the tea species with those two factors, likely to assist in the development of the plants for managing the effect of the climate change. So the best method that I propose is the mitigations, adaptation, and resilience to go with this. And without this, I didn't find the other options beyond this. So with this, thank you so much.
Plus, thank you, Doctor, for providing valuable insights on dendrochronology, and it's been great to see your passion for this field. Our final presenter for this session is Tsering Galton, a data science graduate from Sharapti College under the Royal University of Bhutan. His interests span data analysis, machine learning, and geospatial technologies. During his internship at the Royal Securities Exchange of Bhutan, he helped develop a chatbot to support users with company policies. He has also worked with the National Center for Hydrology and Meteorology, where he and his team analyze key meteorological data for their capstone project. His presentation is titled Time Series Climate Forecasting in Bhutan with the CNN LSTM Transformer Hybrid Architecture. Please welcome Tsering Galton.
Kuzampala and good afternoon to everyone. So today I am honored to present our research on time series climate forecasting in Bhutan with a convolutional neural network, long short-term memory and transformer hybrid architecture. So the study was conducted in 5 western districts of Bhutan, namely Paro, Thimphu, Ha, and Wandifodong and Punakha. So, as we all know, Bhutan faces increasing climate hazards such as glacial lake outburst floods, flash floods, landslides, and unpredictable monsoon patterns, threatening lives, agriculture, and infrastructures. The country's hydropower sector is also impacted due to climate change. So, Bhutan's hydropower sector is vulnerable to changing river flows and glacier melt, creating uncertainty in energy production and water resource management. So to address these growing risks, so this research applied a hybrid deep learning model to analyze historical climate data and predict the rainfall and temperature trends. And how can deep learning techniques be used to analyze historical climate data, uncover hidden patterns, and improve climate forecast is the research question to the study. Significance of the study. So this study provides district level climate projection for Bhutan, which are essential for informing adaptation planning, policies, and guiding risk management strategies. So it also supports in decision making for agriculture, hydropower, and urban planning sectors. So It contributes to advancing artificial intelligence and machine learning based climate forecast in Himalayas. The objective of this research is to analyze historical climate data starting from 1996 to 2024, identify spatio-temporal patterns in temperature and rainfall, and also to develop a hybrid deep learning model for forecasting future climate trends to support data-driven climate adaptation and policy planning. Intensive literature review has been done for this research, including Bhutan Climate Projection Report from NCHM. Some of the key findings are, traditional model like autoregressive integrated moving average and seasonal autoregressive integrated moving average have long been used for predict climate variables. However, they struggle when it comes to nonlinear complex patterns. On the other hand, the CMAP model provides valuable large-scale projections, but their coarse resolution limits accuracy in Bhutan's steep and mountainous terrain. So, emerging hybrid model integrating the transformer, CNN, and LSTM enhance the climate predictions. This architecture combines spatial and temporal learning, capturing long-term dependencies and local variations. Yet, such AI forecasting remains underexplored in Bhutan's unique mountains context. The gap in this research knowledge are lack of high-resolution Dzongkhag level climate projections for Bhutan, limited application of deep learning in meteorological contexts, few studies addressing spatio-temporal variability in the Himalayas, and minimal integration of AI-driven forecasting into national adaptation. So, daily meteorological data, including temperature, rainfall, humidity, wind speed, and wind direction, were collected from National Center for Hydrology and Meteorology, starting from the period 1996 to 2024. So, missing data were handled using cold take and hot take imputations. So, before developing the hybrid model, the initially bi-LSTM model was tested as a baseline model. So, the accuracy for these models were low when assessing using the root mean square error, mean absolute error, and R squared. So, we have developed a hybrid CNN LSTM transformer model. So, CNN layers extracted these partial features. Bi-LSTM layers learned the temporal dependencies, while transformer components modeled the long range sequence. Now coming to the findings. So, Wangdi shows a clear warming trend, as you can clearly see on the graph, with a maximum temperature increasing by 0.42 degrees Celsius per decade and minimum temperature increasing by 0.50 degrees Celsius per decade. By 2055, projected temperature ranges are 27 to 27.5 degrees Celsius for maximum temperature and 17 to 17.5 degrees Celsius for minimum temperature. This indicates strong warming in lower valleys, particularly in Punakha and Wangdi, likely influenced by reduced glacier effect and intense monsoon heating. So, among the western region, so Punakha is the hottest district in the region, where the warming trend also exceeded, same like the Wangdi. So, when the warming trend increases, the evaporation increases, which also increases water loss from soil and vegetation. So, as a consequence, irrigation demand also rises, reducing the agriculture productivity. To bring up the facts, on 22nd August 2023, due to a shortage of irrigation water and post-monsoon, 60 acres of paddy fields were remained fallow. So, unlike rest of the western districts, Thimphu reveals a cooling trend with maximum temperature decreasing by 0.50 degrees Celsius per decade and minimum temperature also decreasing by 0.27 degrees Celsius. Projected temperature ranges from 7 to 8.5 degrees Celsius for minimum temperature and 20 to 21.5 degrees Celsius for maximum temperature. So this suggests a localized cooling anomaly in Thimphu, likely influenced by elevation, urban microclimate, and shift in monsoon dynamics. So Thimphu may also experience frost risks, damage in crops. So to talk about the historical events in Ha, so Ha shows an upward trend in rainfall and rainy days from 1996 to 2024. Rainfall ranged between the 700 to 1,300 millimeters, peaking above 1,500 millimeters in 2024. Rainy days also increased from about 120 to over 160, showing stronger monsoon influence and higher rainfall variability. Flooding events in 2003, 2015, 2021, and 2024 highlights the rising climate risks and the need for climate resilient flood protection and early warning systems. So when we display in the graph, we can see the outlier in 2024. It is likely to be having received more annual total rainfall. On 28 September, due to heavy rainfall, the Hachu have affected the household in Parika village under the Katsu Gyeop. So fortunately, no casualties were reported. So Ha demonstrate a gradual rise in rainfall from 996 to 2055 with an overall increase about 168 millimeters. Despite noticeable year-to-year variations, the long-term trend shows an upward rate of 28.5 millimeters per decade. Discussion. So, temperature projections indicate distinct spatial difference with cooling in high altitude area only in Thimphu due to the machine capturing the historic events of temperature being dropped, and warming in lower valleys such as Punakha and Wadifodong. Rainfall analysis for Ha shows a gradual increase in annual rainfall with long-term projections indicating wetter and more stable conditions. However, it also poses threats so when the rainfall increases, so the risks of landslide, soil erosion also increases. Now to talk about the practical and theoretical implications. So forecasted temperatures and rainfall trends can support adaptive decision making in agriculture, hydropower, and infrastructure design. For example, early warning systems and improved drainage planning in flood-prone valleys like Ha, Punakha, and Wadifodong can reduce risks and safeguard the livelihoods. Integrating AI-based climate forecasts into national framework will strengthen Bhutan's preparedness against extreme weather events and weather-related disasters. So, this study confirms that hybrid deep learning architecture combining CNN, LSTM, and transformer are well suited for modeling complex spatio-temporal climate data, but by outperforming traditional statistical models and by LSTM. So this hybrid model advances the theoretical understanding of deep learning in environmental forecasting. It demonstrates how data-driven methods are completed physically based climate models in regions like limited long-term datasets. To conclude and guide on future research directions, so this study was developed using a hybrid deep learning model integrating transformer, CNN, and LSTM architecture. So the model achieved higher accuracies compared to the baseline model, that is the by LSTM model. So it provided the first district climate projection using AI, revealing distinct spatial variation across the western Bhutan. These findings also contribute in advancing localized climate forecasting and demonstrate the potential of hybrid deep learning models for data scarce and mountainous region. Future studies can expand this analysis to include all the zoncals or also put other parts of the region into this action. to improve national level forecasting coverage. So institutionalizing machine learning approach within NCHM will enable evidence-based decisions for climate resilience and other related activities. These are some of the important references that I have looked to, and I'm also thankful to the NCHM for their guidance and support. Thank you.
Yes, thank you, Tsering, for your research on climate patterns and future trend using meteorological data. And thank you to all the presenters for these insightful and timely contributions. We will now open the floor for a 20 minutes Q&A session, which will be moderated by Dr. DB, whom we invite back on stage, along with the presenters of session 2, Dr. Yishikhandu, Tsering Gyaltsen, and Jambe, whom we have with us online. First, Dr. DB, I hand the floor to you.
Turn it on. Hello, hello. 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 Your Excellency, Nurses, distinguished guests, participants, and the ladies and gentlemen, we are into the Q&A sessions. We have 3 presenters. Mr. Jambe is behind in the screen, on the screen, Dr. Yishikhandu, and we have Tsering, so 3 of us here. It was a very interesting presentation in the sense that some of you might never have heard about the trading analysis, dendrochronology. How many of you have heard this term? Yeah, quite a lot. Interesting. So you could use this technology even to construct the past climate scenarios as well as construct the future scenarios, future climate change scenarios, which is very useful in decision making. Very interesting technology. And we also have mathematical models, ARIMA, which is also hybridized, then that can be useful for making again decisions so that it can be used. We have heard Jambe talking again and again, dying and drying lake, both dying as well as drying lakes, how to restore that in Bhutan. It's a challenge for every one of us. So interesting presentations. So since we have limited time, I would like to open the session for Q&A. Thank you very much. Anybody? Please start last so that we are not short of time. Somewhere in the center, yes.
Good afternoon, everyone. I'm Dawa Charin, a student of Jigmenambi Engineering College. And my question is, though I may be contradicting with my course, my question is, being Bhutanese is all about believing into our superstitions. Though we don't want to, even though a person may be aligned with the science, still we have to believe into our superstition. So my question is that, how can we implement the science while reviving the lake without threatening people's belief that have been already bestowed into them from the very beginning? Thank you.
Jambe, can you respond to this question?
Thank you very much for the opportunity to explain another step that I missed to present in my presentation. In considering all those beliefs it was very much supportive from the chairman of the village. In the sense, what we did was we did an offering to our local deities out there, because I know we are rooted very much with those sentiments, and it's true as well in science. We always have a room for respecting those beliefs. It's not belief actually; it's highly rooted in our thinking. And then we did that as a part of our case study. What we did was we did call the local lama, and then we did a ritual. And even scientifically, people say, why you were calling? I remember my friends telling, why you people pouring lake in the, milk in the lake for water quality purpose. So all those things, nevertheless, in our work, whenever we do, we make sure that both science and our belief are together, whereby we even go up to the level of constructing small stupa nearby the lake in offering to the mermaid that we believe. So we always try to keep those beliefs together, and that's how we approach it. And I think that's same for any science that we are doing. Thank you so much for your question. I'm not sure if I've answered your question, but I'm just giving a scenario that shows how the belief is inclusive in our work. Thank you.
Let's somewhere in the middle again. Another question.
Kuzamola, I'm Tashil Hamola. I work as the Chief Program Officer for Higher Education Quality Council. Very interesting, very insightful presentation. And I can see that, of course, all of us could see that a lot of study has been done, you know. My question is, how much of this knowledge gained is shared with the relevant officers, agencies, you know. We have a ministry that looks into climate, environment, that makes policies. So how much of this information is shared with them? Thank you.
Yes, thank you. Anybody would like to respond to this? Three presenters? Anybody? Rishi?
Thank you so much for your questions. Your question is basically based on the policy base for implementation of the research findings. Now, this mainly lies with the ministries, organizations, and other stakeholders, because the research that what we did, what we have done, that was published online. These are their online. For example, on the international journals, no? These are there. For example, my publication are there online. Now, in terms of my gender climatic discussion, gender ecological, gender hydrological, these are there online now. But I hardly find the less number of users from Bhutan. Rather, I find that many from other countries, for example, USA, European countries, even the Chinese are using my research findings. Even they're asking for the data. Now, here my request is to the ministries, organizations, please step in and to get use of our findings. If they don't step in, how much we make our efforts, you know, to make this happen and to use it for the policy decision makings. And like what, now for example, today's conference, right? I find very limited politicians here. Why are they not here? So that's the question. For example, in my publications, I mostly use the Facebook for the dissemination, and also link the journals with my Facebook. And also even I use the YouTube for sharing what I do in the lab, what I do in the field, what the finding I made. So it's all I do share to the YouTube, Facebooks, and then international journals. So this is what I like to, so I guess for the politicians.
Thank you, Dr. Rishi. Many of the scientific papers are in the web, but then they do not get translated in the language that the common people can understand or the policymaker can use it. So the onus of translating into a policy brief and sending it to the responsible organization so that they can take action also lies with the researchers. And that's where we are also failing as a researchers. We are not doing that job. Just doing research is not good enough, but going behind the research and taking it to the clients is very important for us. That we have to understand. Plus, anything?
Ma'am, from my perspective, so this research is a summarized version of my capstone project, and I have done my internship in NCHM, which is a noble organization for handling meteorological data. So I was solely guided by them, and the using of hybrid model, that is CNN, LSTM, and transform model, was also suggested by Mr. Karmatip from NCHM. Thank you.
Plus, I hope the answer is clear, and let us go for some more questions. Burning questions, please. Yes. You could also shout. You could also shout out the questions. That's better.
Check, check. Okay. Okay. A very insightful research is being conducted by RUBs. My question pertains to both of the researchers, Dr. Ishe and Thrim. Just let me turn on my question. I am a faculty, my name is Bhaskar Sharma. I am a faculty in Jimnam Engineering College. So my background is water resource. So I'm quite interested in this. So I'm also working in temperature reconstruction, not really reconstruction, but working with temperature and precipitation data as I'm working in the climate. And it is very fascinating to see how we can reconstruct temperature data just from the tree rings. And because I'm not from this background, so this I find it very fascinating. Can we also reconstruct snowfall data, I mean snow and other precipitation forms like rainfall from this? And if this is available to the public, because it's already shared, if this is available to the public, then how we can get it? Because a lot of times we have to use this data because these are data that is not available in data scarce region. About 2,500 meters, there is no data. So this can help us get the data available. Then again, you also said that much of the instrument-based data, maybe it is misinterpreted, misrecorded, but tree ring data gives more reliable data. But again, our LSTM model have maybe used the same data, the instrument-based data. So how accurate this LSTM data can be, whether it's calibrated, how it is calibrated, because it's a black box model, I see. So just both of you can answer this one. Thank you.
Yes, thank you. I think you would like to answer from the mathematical perspective, ARIMA model or the hybrid model. The question is about you. Maybe it's good you can, if you can answer this first, and maybe after that we'll talk about dendrochronology. Yeah.
Sir, so I'm not really sure to how to implement glacier data, as I have not overlooked into it. I haven't seen it, and under the National Center for Hydrology and Meteorology, there are different departments: hydrology department, meteorology department, and glacier department. So I have only contacted with the meteorological data sets and the hydrological data sets, dealing with the automatic weather stations and non-automatic weather stations data. And to emphasize on model training, to be specific, so I have used convolutional 1D neural networks to understand spatial features. And in terms of LSTM, I have used bi-LSTM, which are chosen to be good for abstracting long-range temporal dependencies, and multi-head transformers, which are good for long-range dependencies. So these models were judged with the mean absolute error, root mean square error, and R square. higher the value of R square, it shows the good performance of the model. And however, sometimes when the data sets are too less, it can also lead to overfitting, so that the accuracies become so high and the root mean square error also becomes high. So in order to fit the model into a good picture, so R square must be higher, where the root mean square error is the value lost in while training data, so it must be minimal. Thank you.
So from the mathematical perspective, there is a need to train the data for modeling. That's very critical. We need to take a large number of samples in training the data. So that's mathematical perspective. From the tree ring, let's look at it.
This dendro science is the new science to Asia. This was there in Europe and American countries in 1800 later. And this came to Bhutan only in 2022. 2002, and I started my work in 2004. So that's how I reached till now. Now, coming down to the dendro science, dendro for tearing records, and then instrumental records. So this, now, see, it's debated a long time back on this issue, you know. So sometimes when you analyze these two data, we find the divergence. For example, with my first publication on dendroclimatic reconstruction for the northern hemisphere, using the research site from Lunana, Laya, and then single zones. With the recent time narrow, for example, let's say 22 years, there was the divergence between the instrumental data and then this tearing data at the recent time game. Then I sent this my paper and then my data for the review by the world top dendro scientists, and they also commented on this part. And that one what I found was this instruments were made by the human, you know, not by the nature, but using the assay imitations or the copy and paste of the nature ski. Now, while going to the trees, no, trees were there long time back, thousand years before. And whatever the environmental condition, climatic condition, soil condition, whatever condition happening there, you know, even the solar irrigants. I've shown in my presentation, solar irrigants, solar activities, the white spots, when they are developed, the sun continuously changes, you know. It's not there for permanent, it changes. So when the sun, the spot changes, you know, there's an influence on the Earth's surface now. So therefore, affecting the increase and decrease of the temperature with the solar activities, solar irrigants. Now, the trees, you know, exactly recording, you know, what occurred in and around the trees. So there's no any misinterpretations. There's no any error with the trees. With the provided that we exactly follow the principle and technique of the dendrochronology and exactly use the tearing and climate data analysis. If this is used, I think tearing is the best as compared to the instrumental. Now, if you go with the Bhutan temperature, you know, Bhutan meteorological station data, in the northern expert, very exposed, very scarce. But when I was doing the research in those high altitude regions, no data in most of the region. And even that they have, you know, for example, single zone, that was just some years back, and then later on, after using 2 years, it was left like that. It was gone. So not functioning. Yes. So now see, again, either they are in other mistake. For example, if you go with the Popchua instrument data, so either are there. So not only in Bhutan, in other countries also, they face the similar condition. So therefore, I go with the Kiringi data. With the condition that you should have the human exposed and then resources to go with this.
Yes, thank you, Dr. Isse. Maybe since the time is up, I would like to ask the presenters to give the key messages, take-home messages. So let us start with the colleagues behind. Jambe, do you have any key message for the groups here?
Thank you for an opportunity. My key message would be like, if we take care of the catchment, then we will be able to take care of the lake. If we take care of the lake, then we will be able to take care of the spring. And if we are able to take care of the spring, we will be able to take care of the river. So all of them are interconnected and beautifully. So we should always start taking care of the catchment as it is. Thank you.
Thank you, Zambe. Dr. Isse.
So my specialist in tornado science. So I like to suggest and also to advise the younger generations to come forward to take this tornado science as a your field. And very limited people are coming. So for only I am working really at the advanced level in terms of the general climate and ecological analysis using the technology. And is the take-home message I like to share what Som from Simdaha gave. That she mentioned that she was not joking. She was serious. So now I'm also serious to go with this. So therefore, to go with the rising of the temperature, shifting of the tree line towards the higher altitudes, and what about the shifting of those lower altitude crops for the higher land, so that may perform the better yield. And with this is my take-home message. To so possible now, with the constructions I have shown there, in the past 1400 and 1500 years, they were very warmer period, high rate. Now comparing this to time spent, with the recent, very high as per the tree lines, as per the tree ring records, as per the tree ring index construction, very high. So therefore, it's a very alarming for us. So we must take up the actions now. So therefore, with the mitigation, adaptations, and then resilience. So beyond this, I don't find other mechanisms. Thank you so much.
Yes, thank you, Dr. Isse. Richard.
So from my suggestion that climate change cannot be stopped easily, but it can be reduced. So everything that we do needs to be taken care of. So particularly the waste. So many people are dumping their waste and burning it, which results in burning of carbon monoxide and consumptions of fossil fuels. So if these things can be handled properly, so the climate we face in the next after decades will be changed, and the world will be a better place to live. Thank you.
Yes, the three colleagues have summarized their key messages. Let me add something on this. Very critical for us is that just being the climate change informed citizen is not good enough. That's what I have already told. What is important for us is that we need to go a little bit behind that. So to become the climate change educated citizens, that's how we build the climate change, the society, basically our society has to be educated in terms of the climate change events and the impact. So this is very important. Climate smart citizens of the society is very important to build. That is very important. And another message that I have is from this discussion, as a researchers, do not stop your research in the publishing alone, but take it to the client where it is supposed to be. Take the findings to the clients and sell your research output and ideas. This is our responsibility as a researchers. With this, thank you very much everybody for your patience. I would like to close this session. Thank you all.
Thank you, Dr. DB, and thank you to all the speakers and participants for a very interesting discussion. We will now take a short, roughly about 20 minutes tea break. Please make sure to return on time, that is 3:40 p.m., as we are on a very tight schedule. And when we return, we will continue with session 3 on the same thematic area. Thank you, and see you shortly. Where we shift our attention to research on clean energy access and aquatic biodiversity, two themes that profoundly shape Bhutan's development pathways. Our first presenter for this session is Rinzin Dema, joining us online. She's a PhD candidate and sessional academic at the School of Economics and Finance, Queensland University of Technology. Her work focuses on clean energy deprivation, energy poverty, and the evaluation of policy interventions in developing economies. She has previously served as an associate lecturer at Sherapsi College and a research associate with the South Asian Network for Development and Environmental Economics. She will present on the topic, Uncovering Clean Energy Deprivation in Bhutan, a multidimensional analysis of household energy use. Ms. Rinzin, can you hear me?
Yes, La.
Okay, that's loud. You may begin, La. Thank you.
Yes. A very good afternoon, La. Your Excellency, the Ambassador to Australia, Honorable Vice Chancellor, esteemed delegates and friends. I would have been really happy to, come there personally and present. However, I'm happy to be virtually engaged with the people here. So my name is Rinzidama, and today I will be presenting a piece of my work, which is part of my research, my PhD research under the supervision of Professor Vincent Hong and Professor Clever Wilson. The title, Uncovering Clean Energy Deprivation in Bhutan, a multidimensional analysis of household clean energy use. So to begin with, Bhutan's energy landscape is dominated by hydropower, and we could proudly say that 99% of our electricity comes from hydropower, which is extremely clean and sustainable. Considering the way considering the sources and the way we produce it, and we could also say that we are near self-sufficiency in terms of electricity generation, and we have been the net exporter of electricity since 1990s. If we look at our electricity generations and also the export and import, we could see that our total electricity generation has been increasing over the years, and we could also see that our export sale makes 67.14% of our total electricity sale. However, having said that, though we have been at the net exporter, it's not because we have abundance in production. However, because we were not capacitated enough to distribute our production in the domestic market. So if we look at our energy, the total energy supply mix in the market, we could see that the huge chunk of that total energy supply in the market, which is 34%, the huge chunk is from the biomass. And on the other hand, if you look at our electrification rate, we are near universal electrification rate by 2022, which is approximately 99.71%. So, however, when you look at again the energy directory book published by Department of Energy in 2003, so we see that 82.4% of our total firewood consumption goes to the residential sector, of which 36.2% is being used for cooking, 22.5% is used for heating. So when we look at this figure, we could sense, we see that there is a gap in our universal electrification and also the use at the household level. So we see that there is a gap. Our energy use has not, our household has not fully, or has not is taking time to transition to clean energy use. So this study generally tries to explain this gap. Okay, why there is this, why there is this gap, which is the clean energy deprivation. So we see that there is clean energy deprivation because our households are depending more, like there is considerable share of biomass being used for heating and cooking purpose. So before I go any further, I would like to define what clean energy deprivation, what clean energy is. So clean energy is a term that groups energy sources, applications, related assets that are compatible with net zero emission as per the International Energy Agency. And this clean energy deprivation is a phenomenon of energy poverty. And this not only explains whether the households are connected to the grid or electricity, but we also measure whether the energy that are being consumed by the households are clean. So at household level, the clean energy deprivation captures the ability to obtain and utilize modern, safe, reliable, and environmentally sustainable energy services. So what really motivated this study is, first, there is a policy blind spot in Bhutan. Like there are not many studies done on our energy landscape, and clean energy deprivation, and most of all, the clean energy deprivation is not explicitly recognized, or like that gap is not being explained. So, and also this study is very relevant to the Sustainable Goal 7 of clean energy, and also our recent national energy strategy from the Ministry of Energy and Natural Resources, and also transitioning, like energy is not only transitioning to a cleaner energy also has a broader impact on the health, gender, environment, and social injustices. So this study has three specific objectives. The first one is the study tries to identify household energy use profile, like to what the household. The study identifies like whether the household is deprived or not deprived, or are the transitional users. And the second objective is to examine socioeconomic and geographic determinants, like what actually makes what factor pushes the household to be more energy deprived than non-deprived. And the third specific objective I have is to map the spatial disparities of clean energy deprivation. So where are these households located in our country? And to give a brief literature on like energy, the literature on energy poverty has come a very long way. Like it's the understanding on energy poverty has developed from access-based, infrastructural-based measurement to more multidimensional base, and also over the years there is this methodological advancement. Like in the earlier studies, though the concept has expanded, but the measurements were limited by the composite scores or certain thresholds put by certain scholars and researchers. So the literatures found that this actually marks the actual heterogeneity, like the differences that household experiences in terms of energy deprivation. So recently there are more the latent class modeling has gained its popularity in actually classifying classifying or observing this unobserved heterogeneity in the study in the area of social sciences. So this study also uses latent class modeling to identify the households' clean energy deprivation. And in this study, I draw on the socio-technical transition theory, where particularly the multi-level perspective to explain why clean energy deprivation persists in Bhutan despite our near universal electrification. So the socio-technical transition theory actually explains how the large systems such as energy system evolves over time through interaction among technology, institutions, social behaviors, and it also says that change does not occur through technology alone. It depends on how new technologies fit or clash with the existing regimes, existing landscape, existing rules, policies, infrastructure, and cultural practice. So in the case of Bhutan, the hydropower dominated regime, in the case of Bhutan, the electricity or the clean technologies are considered the niche innovation, and then for this niche innovation to develop or to penetrate in the market, they like the factors like the socio-technological regime, like rules, policy, price surrounding these substitutes, energy substitutes in the market. So this should facilitate this niche market, and then this niche, and through this again we have like the broader landscape, which we call that socio-technical landscape. For example, the deep structural trend or traditional practices, or the cultural and the traditional the cultural practices that is integrated with the energy system. So these factors, if these factors, keep the households locked into the traditional practices and practices of energy use, traditional energy use, and because of which, which would possibly explain why our households are not being able to transition to more cleaner energy systems. So for this study, we use the data Bhutan Living Standard Survey 2022, and yes, so yeah, we use latent class modeling to observe to classify the households into different categories. And for this, there are two sets of variables. Like the first one is the manifest variable that actually those are actually the observed variable that help us classify, or that help us group the household into different categories based on their item response probability. And also the predictor variables that actually talks about what factors surrounding the household pushes the household to more deprived or transitional user or clean energy users. So to begin with the results and discussion, our results shows that 16.94% of our household belong to clean energy deprived group, and 36.38% in the transitional group, and 46.68% in the clean energy users. So those are non-deprived, and 16.94% are deprived. And this latent class, this profile is based on the item response probability of like electricity access, lighting, the type of cooking fuel they use for, the type of fuel they use for cooking, the type of fuel they use for heating, and also their clean energy expenses. And our latent class regression shows that the type of materials used by the households in construction of their houses are some of the most significant significant factors that pushes households into like the clean energy deprived group. And also we also try to look at the distribution of where these deprived households are located, where these transitionals are located, and then where these clean energy users are located. Generally, our deprived households are evenly located in all Dzongkhags here, and it is comparatively lower than the transitional users and energy users. We do not see like much differences among the regions here, among the Dzongkhags here. However, when we further dissect these clean energy deprived groups into urban and rural, we see that it is more pronounced in the rural area. So, and further, our peripheral regions like the eastern region, southeastern region, the extreme north, and then the southwestern regions are more deprived than the central regions here. So more households in these areas are more energy deprived. And similarly, we try to dissect these transitional users and clean energy users into rural and urban areas, and we
Ms.
again,
Yunsen? Hello?
Yeah?
Sorry. Can you hear us now?
Yes, yeah.
Oh, Lasla, the bell was a warning bell. We're a little over the time limit. If you could wrap it up in a...
Okay, sure.
Oh, Lasla.
So, yeah. So we have more transitional rural users in the rural area and in the urban and more clean energy users in the urban areas, and also like the rural areas in the western part of the regions are doing well with transitioning to more cleaner energy. So now to conclude, like from our study, what we see is like near universal electrification does not always convert to clean energy use. So there is this gap, and what are these factors? Those are the socioeconomic, the regional factor, the geographical factors mentioned above, and also heating remain as one of the major barriers. Housing and infrastructure lock-in of the traditional homes, like at niche level, we see emerging clean energy adoption, such as electricity cooking, appliances, efficient heater, LPG, slowly diffusing into the households. However, at the regime level, the dominant energy system in Bhutan still shaped by our traditional heating practices, the biomass availability, housing structure that are poorly insulated, and policy frameworks that prioritize electrification and hydropower exports, but do not explicitly or sufficiently target clean energy heating or cooking. So yes, we also we have few policy implication here. Maybe like the most important one that I can highlight here is in maybe integrating our energy policy and also the housing policy while we retain our traditional architects. Maybe like promoting awareness in the rural areas where the households are mostly impacted. On the insulations or retrofitting. This actually helped in the rural areas in Asia. Thank you.
Lasla, thank you, Ms. Rinzin. Sorry for rushing. Thank you for your insightful presentation on clean energy as well as clean energy deprivation and its implications. Our next presenter is Ugen Doji. Sorry, Ms. Rinzin, please remain online for the Q&A session that is going to start shortly. Our next presenter is Ugen Doji, Assistant Professor and Head of the Center for Environment and Climate Research at the College of Natural Resources. His research focuses on aquatic biodiversity, freshwater conservation, and sustainable water governance. He has led over 30 national and international projects, authored more than 60 publications, and contributed extensively to capacity building in Bhutan. He will be presenting on spatio-temporal profiling of aquatic biodiversity in stream habitats in Gelifu Mindfulness City. So again.
Listener, Kuzambo, and a very good afternoon. Truly delighted and pleased to end the speaker session today. It's a privilege to speak at this conference and to share some of my work that's very close to me, both as a freshwater ecologist as well as someone living in the remarkable transformation taking place in the southern Bhutan. I'd like to present the first ever spatio-temporal profiling of aquatic biodiversity in stream habitats in Gelifu Mindfulness City, Bhutan's upcoming positive nature economic hub. And I was recruited by Gelifu Mindfulness City project for about 6 months last year, and they gave me all the freedom to collect the data, do the planning, and give them the finding. And this is one of the findings from that project. To give you a background about the study, Himalayan aquatic biodiversity system is considered as one of the global hotspots because of its rich endemic biodiversity. And secondly, Eastern Himalayas, including Bhutan, is also considered as one of the underexplored aquatic biodiversity areas. And rapid urban development taking place in Eastern Himalayas calls for integrating the ecological conservation with urban design. And if we do not consider the ecological integration when we are doing the urban design, river habitats are getting defragmented and sediments come into the river. And if we do not carefully maintain these ones, the flow regime of river gets disturbed. And at last, aquatic biodiversity is impacted. Gelifu Mindfulness City project presents a unique opportunity to integrate the ecological conservation and climate resilient urban design. But the question is, how do we do this without compromising the aquatic biodiversity? And my research answers this one, and specifically looking at the river system. We had 3 objectives when we carried out this one. We wanted to check what are the fishes, invertebrates living in the water, and what are their spatial and temporal distribution, firstly. Secondly, we wanted to check how eco-hydrological characteristics, these are characteristics like depth of the river, velocity of the river, the substratum that fishes and invertebrates live, how they are influencing diversity and distribution. And thirdly, we wanted to check how our work would generate baseline data for ecological zoning in GMC. And for that one, I would like to share brief methodology. We carried out the study in Gelifu Mindfulness City. It took us about 7 to 8 months to carry out this one. And the study was carried out in Gelifu, Tarathong. You must have seen the rivers and streams flowing through Gelifu Mindfulness City through the Jarke angles and video mostly. Those are the rivers that we studied. And our sampling design included 200-meter transects, and these were systematically placed between 1 kilometer distance, and all the points that we collected were georeferenced. 2 seasons, monsoon, because monsoon has high flows and dynamic conditions of the substrate and the flow. And second is post-monsoon, because post-monsoon has a very stable river nature. And if you look at the habitat of the river, it's stable again. So these are the 2 conditions that we took into consideration. We focused on many things, but for this conference, I just would like to focus on the fish sampling and macroinvertebrate. We use almost all the equipment and sampling method that had in our expand. We use cast nets, cyanide, temporary diversion, electrofishing, and all the fishes that we caught. We caught about 1,200 fishes together, just about 500 to 600 kilograms. But strict catch and release protocol was adhered. And data were analyzed using Shannon-Wiener diversity indices. Data were abnormal, so we use all the non-parametric tests, and also we use negative binomial GLM regression. And everything is done in R. I love R. So everything was done in R. I'll just give a few results of discussion. The first one is fish. There were 35 different fish species encountered. Very different, lovely fishes. If you look at number 4, 1, 2, 3, 4, the name of this fish is yo-yo fish. Very interesting, mostly. We found 35 different fishes from the study. And we found that monsoon had higher diversity compared to post-monsoon. But it's very important to note what I'm going to say next. Monsoon had higher diversity compared to post-monsoon. But monsoon had lower abundance compared to post-monsoon. So we're getting more fish with less diversity in post-monsoon. However, we are getting higher diversity with less number of fish in monsoon. This one. So this is all about what I just said. The other object was to look at spatial and temporal variation. After going through the analysis, I would like to share 3 things. The first thing is between the 2 seasons, monsoon and post-monsoon, there was a significant difference. Post-monsoon had higher abundance of fish compared to monsoon. This is very important. That's the first finding. Second finding says that between different habitats, we are comparing habitats of river. For example, let's say this is a river, and the river has different substrate. The wooden plank, the stage, the chair, the table. We wanted to see whether fishes were found more on wooden plank or on the table or on the chair, ensemble, different way. But interestingly, we did not find any significant difference between different habitats. That's the second thing. Third thing, we also did not find any difference between all the streams and rivers that was flowing through the Gulf of Mindfulness City. So almost all the rivers had similar count and diversity of fishes. And this was again run through in different modeling and statistical tests. One of the tests that we ran was negative binomial regression. And it said that post-monsoon, of all the factors that we incorporated, post-monsoon was the specific factor that was explaining the diversity and count of the fish. So if you're someone else working in Gulf of Mindfulness City, you would get more fish if you go to the Gulf of Mindfulness City in which season? Post-monsoon, because all the tests, all the data says that post-monsoon you'll get more fish. Second thing, macroinvertebrate. These are very critical to freshwater health. Invertebrates, insect living inside the water system. We collected about 1,100 insects belonging to 14 taxa under 9 orders. And there are specific groups of insect by the abbreviation EPT. E stands for Ephemeroptera, P stands for Placoptera, and T stands for Trichoptera. And you find EPT anywhere in the river is a healthy river. And luckily we found EPT in Gulf of Mindfulness City rivers. And we concluded that these rivers are healthy. We again ran the same test with the macroinvertebrate invertebrates. And this time we found slightly different thing. We found that between 2 seasons, there was no difference, statistical difference, no statistical difference. However, between different sites, the river flowing through GMC, different sites, we found that there were statistical differences, meaning some of the rivers which were flowing near the settlements had lower, and some of the rivers which were pristine in the forest had higher. So that was obvious mostly. So between the sites, there were statistically significant differences. But between the habitat substratum, like this ones, we did not find any differences. And the discussion, I would like to bring 4 things here. 4 very specific things here. The first thing is always the post-monsoon. So the post-monsoon explains many things. Post-monsoon brings a stable river flow. And post-monsoon also brings a very homogenized riverbed. So therefore, you're getting more fish. If you look at post-monsoon again closely, post-monsoon also brings less diversity. So you're getting few of the fish in higher abundance or higher count, like the ones that you see in Brownla. These are not the images which I got from internet. These are the real fish that I got from the GMC. This is the second discussion I would like to make. The third one is, I would like to say that Galefu Mindfulness City is ecologically compared to the river health, river integrity, it's healthy. And I would also like to bring that there are some pockets in the rivers in Galefu Mindfulness City where these kind of insects, the red ones that you see, these are under insect group called as Diptera, the house flies, worms, most larvae. And these were found in pockets, in pools of some of the rivers. And these are also signs of bad water quality. So only few pockets and pools of Galefu Mindfulness City rivers had only pollution tolerant species. And in conclusion, I would like to conclude 4 things. The first one is the seasonal shift is there. Monsoon, high diversity, low count, post-monsoon, less diversity, high count. Second is we found EPT. Very thankful we found EPT and we could conclude that the rivers in Galefu Mindfulness City is healthy. The third one is it's very important that we preserve and conserve the habitats, different habitats of Galefu Mindfulness City. But also be aware that there's some pockets where the pool formation, where the pollution tolerant insects are there. That has to be taken into precautions. The fourth conclusion that I would like to make is the drivers of biodiversity, specifically aquatic biodiversity, are hydrological regime. That means different flow than substratum diversity, habitat complexity. And if you have to recommend, we recommend specifically 3 things. First is ecological zonation, when we are really looking into how to protect the rivers of Galefu Mindfulness City. We would like to protect those portions of rivers where fishes are found the most. It's not that you have a river and you're happy. You have to go inside the river and protect every stones and pebbles. It's not just protecting the fishes, but also protecting the stones and pebbles. We should not let dredging activities happen if the stones and pebbles are there, because it's very important for fish habitat and spawning, reproduction. Second one, whatever urban design that we're proposing, it has to be season friendly. Season sensitive bridges, meaning season sensitive bridges are bridges which are made considering both the seasons. You're considering not just the dry season and you make the bridge, but during the wet season, the rivers are going outside the bridge. That doesn't work. So it has to be season sensitive bridges. The third one is in every ecological monitoring plan, we integrate the aquatic biodiversity into the plan. That's it from my side. Thank you, everyone.
Laszlo, thank you again for your very interesting and first-of-a-kind research on aquatic biodiversity at the GMC, and especially important because we want to preserve them and not disrupt their homes by our urban designs. We now open the floor for a 10-minute Q&A session. I'd like to once again invite Dr. DB to moderate the session along with the presenters, Ugindoji and Rinzin Demma, who we have with us online.
Sorry for showing my face again and again all in the same afternoon. So I assure you this will be my last time I'll be showing my face on the stage today. Your Excellency and also distinguished guests, the participants, ladies and gentlemen. We had very interesting sessions after the TILA. Very interesting. So one is related with the Galepo Mindful City. And the other one is something to do with the clean energy at the household level. Very important for us from the perspective of the health. If we have a dirty energy in the house, that's it, we are fixed. We'll have health hazards, lungs disease, tuberculosis, maybe, I do not know what, I do not know anything about the disease, but then it's possible that bad energy in the house could bring so many bad effect in the, even in the personality of the people living in the house. Since the time is limited, let me open the session for discussion, Q&A. Anybody from the floor, please. Yes.
Interested to know. You did mention that some fishes are pollution resistant. No, I mean some insects.
Yes.
And you were suggesting, we should be cautioned about this. Are there any measures to deal with this so that the water system, the water body becomes much more healthier? Am I clear?
Yes, definitely. May I sit and talk, or? Okay. Let's thank you for the wonderful question. Macroinvertebrates, I did not find a good time to explain because we were just given 10 to 12 minutes. Now I'd like to explain clearly. There are a set of invertebrates. For example, you must have seen dragonfly, mostly dragonfly. A dragonfly lay their larvae, lay their eggs in freshwater system. And when they lay their eggs in freshwater system, the quality of freshwater system is being determined through the kind of insect that is laying down. The larvae of dragonfly, if you find larvae of dragonfly in the river system, then the river quality is moderate. It's not very healthy, it's not very poor, it's moderate. And there are insects like housefly and other different flies. If you find the larval looking organisms in the river, then the river is polluted. And the last one is the mayfly or any other flies like looking like mayfly, which has 3 tails and all. If you find those, these are indicators of perfect quality water. Because some of the flies, they lay their egg and develop their eggs only in good water quality. And some of them in moderate, and some of them in bad. For us it's bad, but for them it's the moderate condition. Now coming back to Lumis' question, if you find those larvae which indicates bad water quality, then we immediately say that the water is polluted. And that's also tested by using any kind of physical, chemical parameters and checking kits. You can check there and the pH will be either high or low. The other chemicals will be high or low. Now to mitigate those is to make that stagnant water. Usually the waters are stagnant. The polluted waters are stagnant. And that stagnant water has to be converted to a flowing water. Because as long as water flows, the water has more oxygen and it's running, so it becomes good water quality. So we need to convert the stagnant water to the flowing water. One of the bad water quality indicator is the larvae of mosquito. So if you find mosquito larva, then that's bad. We instantly know because the water is stagnant. In the drain, the water is stagnant and you get the mosquito larva, then it's bad. So what we do immediately is we wash away the water, then we make the water flow smoothly, and the water becomes a clear water and good water quality. So the best answer is to make the pool which has low oxygen and low flow to have high oxygen and high flow.
Yes, thank you again. Hopefully it answers your next question. Anybody in the floor? Please, yes. Since Ranjan Dema is not there online, so please the question should be targeted to Ugen Durzila. So all questions.
So my question is that Sir has mentioned that finding that there was no significant difference between the fish distribution and the substrate. So is it possible that the fish were moving too much or fast between the habitats, which made it hard for the researcher to detect a clear relationship between the substrate type and fish distribution, sir? Thank you.
Lusla, it's not exactly like that. Fishes will be on different substrates. That's the first thing. Second thing is we are testing this statistically. So there were few fish, for example, 10 fish on stones and 11 fish on boulders. If you look directly, we have more fish on boulders compared to the stones. But if you test statistically, then there are no significant difference. So what I was trying to present is there were differences in number, but there were no differences in statistics. So statistical difference they may know, but number the difference you learn. If you consider here, one side we are about 300, one side we are about 259. We are more towards this side, less towards this side, but if we test statistically, it's basically the same because it's statistical difference significant in the world. So I was trying to see that thing.
Does that answer your questions? Yeah. All right. Any more questions? Yes, please, sir. Last questions.
Last, thank you for the opportunity. My question is to Ugen also. Mr. Ugen, I thought this was one of the most wonderful presentations so far. And I would like to, congratulate you on this. And also very interesting and very important topic. And my question would be, because in Gelifu, mindfulness city, a lot of constructions, lot of works are going on, establishment works are going on. And I'm quite sure the river, the life system, river system, the biodiversity would be compromised. So what would be some of the interventions, preventive interventions that the Gelifu Mindfulness City Authority would be adapting to preserve the biodiversity, and the river system and the river life system? That's the answer.
So again, while you are answering the questions, at the same time, can you also summarize the key take-home messages? Is it okay?
Yes, sir. Thank you so much for questions. This work was very critical. If you did not do this work, then we would have proceeded with the developmental activities. And in later part of the stage, when all the development activities are being done, we would not have known what exactly was there before the development. So this was quite critical. Secondly, we have to exactly map which substrate, what kind of depth, what kind of velocity, what kind of water quality was there on which kind of fishes. So that even if it is destroyed right now, in future, if we have to bring it back, we exactly simulate that kind of substrates. We exactly bring pebbles, we exactly bring the big rocks. If you, I can also share, because this is being published now in the first page of the special edition. I can also share the data. All the rocks are being measured. And this rock is being measured. On the pitch Thomas, this rock has been measured. So that when we bring it back, if you have to bring it back in future. Right now, there's no talk on bringing it back, but if you have to bring it back, this should be possible. What we're trying to do is we would like to bring it back, if you have to bring it back. I've heard somewhere that before Bangkok was developed into the city currently it is, they had the similar studies, but terrestrial biodiversity, birds and so. Later, after the development, obviously the biodiversity is going to be hampered, but after the development, if they have to bring back what kinds of birds were there before, if they can bring back, what kind of conditions that we need to set up. So they're trying to bring back right now. And if you have gone, you must have gone through mostly. There are birds chirping, and these are the exactly interventions before the after gila. But I'm specific study detail. So we are quite confident. My team is quite confident that we can bring it back if you have to.
That's it. Your key message is already there.
Yeah, the key message is thank you. I not just worked in GMC, but I've worked almost in all the hydropower sectors with BPC, all the major construction activities going on in the country. If it's pertaining to river, I've worked with them. If you would like to join with me, you're welcome to. First thing, and the message is, rivers remember everyone. And rivers remember the disturbance that we have made to them. Rivers remember the restoration project that we bring to them. And most importantly, rivers remember the choice that we make to the rivers. Thank you so much.
Yes, thank you. Thank you again. Since Ranjan Dema is not there, let me take this opportunity to send the key message from our side. So I spell the key message from my side. What Ranjan was basically also saying was that the hydropower energy alone is not the only clean energy sources, not the only clean sources of energy, clean energy. So there are other sources. So we need to also look into these issues, which we are not yet there. So perhaps, so depending solely on the hydropower energy as the clean energy, perhaps it's not correct. That was one of the messages that I got from our presentation. So since Ugen has already given the other perspective, so I would like to wind this session up. So I would like to get out of this stage before the organizers throw me out. So once again, thank you very much, all of you, for listening to this afternoon session, very interesting session. Thank you very much.
Yes, thank you so much, Dr. DB. And so again, we're so sorry for rushing you. As said, we're a little bit tight on time and trying to be a little more time conscious.